So in this case, we have a situation where the pharmacist is requested to make 200 milliliter of 5% albumin solution, but he does not have exactly 5% concentration, but he does have a higher concentration of 25%. From this 25%, he has to make 5% concentration, but the first part of the problem wants us to determine the specific gravity of the stock albumin solution, which is 25%. And we have been provided the information about the pycnometer, the tare weight of the pycnometer, which is 28 gram, then the size of the pycnometer, which is 25 milliliter, and the weight of the pycnometer containing the albumin, which is 58 grams. So the first part wants us to determine the specific gravity of the albumin solution, which has a concentration of 25%. So let's first try to draw the picture of pycnometer. Let's say this is our pycnometer, and its capacity is 25 ml. All right, so the blank weight, the tare weight is, the pycnometer is 28 grams. And the weight of pycnometer plus albumin is going to be 58 grams. So if you subtract these two numbers, you should be able to get the weight of albumin alone, which is going to be the difference, which is 30 grams. Now from the size, from the volume of this water, we know that the weight of this 25 ml of water should also be 25 gram. So the weight of water is 25 gram. Now if you look at the definition of specific gravity, the specific gravity of any substance is the ratio of its own weight and the weight of water occupied by the volume of that substance. In other words, in this case, the specific gravity of albumin will be 30 grams divided by 25 grams. So let me draw a line to show that they're being divided. And the answer 1.2 would be the specific gravity of this albumin, which is actually 25% stock. And it doesn't have any unit. This is just a number. This is specific gravity. This is not density. So we're done with the first part. We know that the specific gravity of this is 1.2. 1.2. We know this. So the second part wants us to determine how much of this stock solution, 25%, should we need in order to make 5% of this 200 ml, 2000 ml of solution. So the formula in this case should be the V1 times C1 equals V2 times C2. The V1 would be the initial volume, the C1 is the initial concentration, V2 is the final volume, and C2 is the final concentration. So let's see, let's say 25%, the higher concentration is the initial status. So in here, we can write this is going to be unknown. We don't know the volume, X, but we know the concentration. This is going to be 25%. And for the later on, the V2 is known. This is 2000 ml. And the concentration is also known as 5%. So we plug these numbers in the equation and it gives us the V1 would be 2000 ml times 5% divided by 25%. So the percent signs go away and we only have a volume of 400 ml. So we need 400 ml from here, 400 ml from here to make the diluted concentration, which is 5%, but the volume will be 2000 ml. Now, let's move to the third part, in which we need to determine how much of the normal saline we'll need in order to make the 2000 ml of the preparation. So let's draw another picture. Say this is the large container, in which we're gonna add 400 ml from the stock, and definitely we'll need 1600 of normal saline, because the total should be 2000 ml. This one has the specific gravity of 1.2. We already found out in the first step. And in here, the literature search says the specific gravity of normal saline is 1.5. 1.5. So if you multiply the volume expressed in milliliter with the specific gravity, you should be able to get the weight. So the weight of this top part is going to be, let me draw in here, 1600 times 1.5, which will be 1680 grams. And this one, the lower part, will be 400 ml times the specific gravity of 1.2 equals 480. That is why the total weight of this entire content is going to be this one. Let me put the unit of gram in here. It's going to be this one plus this one. So the total weight is going to be 1680 plus 480, which is 2160 grams. Now the last part of the question wants us to determine the specific gravity of the entire preparation. So again, the specific gravity should be defined by the weight of the substance divided by the weight of water occupied by that volume. So the weight of water having the volume of 2000 ml is going to be 2000 grams. So the specific gravity will be the ratio of these two quantities, and it should be equal to 1.08. So this is the final answer. The specific gravity of the entire mixture of 2000 ml of 5% albumin preparation.